Markers back here.
All right, we're going to start. So our next unit is talking about polynomials, and today we are just going to talk about the attributes and the end behavior again. All right, so you're going to see kind of some repetitive things that we have already talked about. Now let's first talk about what a polynomial is. A polynomial is a function of x degree, a function of x with degree n where the leading coefficient is a sub n. So what this means is, quit talking. I have the variable x in my equation. My exponents are a regular old number. And then my coefficients are going to be just anything in the front, any number in the front. So this expression right down here, it kind of looks confusing just with all the notation. So don't worry too much about that. The big thing with a polynomial is that there are no fraction and no negative exponents. All right, so a polynomial, you cannot have a fraction, you can't have a negative exponent. It just has to be x to a regular number, or x and then plus x to another regular number, plus x to a regular number. So no fractions, no exponents for it to be a polynomial. We've already talked about the degree. The degree is the term with the highest exponent. That would be your degree. And the leading coefficient is the coefficient with the term of the highest exponent. So the leading coefficient is the number in front. The degree is the actual exponent. And then turning points are kind of new. Turning points is going to come from the degree. And you will have at most one less than the degree. So if I have a polynomial of a degree 5, which means your highest exponent is a 5, at most your guy is going to turn 4 times. And so when I say turn, like when you're graphing it, it will go like this. It will turn, it'll be like a max or a min. So it'll go 1, 2, 3, 4, 5. And that's what your polynomial at most could look like. So if you had like a degree 3, at most you could turn twice. So it would snake, it would go like 1, 2. And so it would kind of look like a snake. Right. And if it was a quadratic, like a degree 2, how many times can you turn for a quadratic? Once. And so it'll just go like that, like a U, and it'll turn 1 time. All right, so it all kind of matches up. Now, you don't have to turn that many times, but that's the most you can turn. All right, so down here, I'm going to give you a function, and we want to figure out the degree, the leading coefficient, and the max number of turning points. All right, so on number 1, what would your degree be? 4, yep. Because the x4, that's the biggest exponent. Now, what is the number with that x4? Negative 9.
I have it before, but I have it right now.
All right, so your leading coefficient is negative 9. You do need to make sure the negative follows with it. All right, so since I have a degree 4, how many turning points could I have?
3.
You don't have to have 3 turning points, but that's the most this function could turn. So it could go 1, 2, 3. And is this a polynomial?
Nope.
Yes.
What's negative side?
Because the exponents are regular numbers. So when you're talking about fractions and exponents, fractions and negatives, I'm talking about the exponents. So the first one's an understood 1, the next one's a 4. So regular numbers, no negatives, and no fractions. All right, on 2. Is this guy a polynomial? No, because what does it have that makes it not a polynomial? The square root. And so the functions that have the square roots are actually called radical functions. All right, so not polynomials.
So then we got to change the rule to no fractions, negatives, or square roots. Because that was a trick.
Mm-hmm.
Is the degree 2?
Kind of. So it doesn't totally make sense to talk about the degree, leading coefficient, and turning points if it's not a polynomial. So we're not going to answer these questions because it's not a polynomial. So it's funny trying to talk about those kinds of things if you don't have a polynomial function.
So can we
My homework.
it won't be a polynomial
If it has any kind of root, it won't be a polynomial. Yep. All right, what about example 3? Not a polynomial. Why is it not a polynomial? The negative exponent, which is no good. So really what that negative exponent is going to do is it's going to move that x cubed to the bottom. Because negative exponents are just fractions. So it's going to move that x cubed to the bottom of my fraction. And so this guy is not a polynomial function. What kind of function is it when x is on the bottom? Rational. All right, so when x is on the bottom, it's a rational function. All right, on example 4, is it a polynomial? Yes. The 1/3 is a coefficient, not an exponent.
Rules need to be changed,
What do you mean?
It's a fraction.
It's not an exponent. It's not an exponent.
The fractions chill though.
So, no fractions unless sometimes there's a fraction.
No, but that's
Square root
exponent.
exponent.
But that
Exponents.
fraction's not like weird or anything.
No negative exponents, no fraction exponents.
No
David.
fraction or negative.
David,
Oh, so
if it looks
I
hard
get how
to
you
do-
read it wrong.
Yeah, you read it as no fractions and no negative exponent, but it's no.
I
Yeah.
feel like if it looks confusing, it's not a polynomial.
But good point.
All right, no fraction exponents, no negative exponents, and then if you want to add, no radical signs. Okay. So what would the degree be?
3.
3. And then your leading coefficient is going to be
-5.
-5. How many turning points are you going to have? Could you have?
2.
2.
Wait, why is it 2?
Because it's 1 less than the degree.
Oh, so you just subtract 1 degree.
Okay, let's go to number 5. Is that guy a polynomial?
Yes.
Yes. What's the degree?
4,
4. What is the leading coefficient?
-5.
-5. And how many turning points could you have? 3.
Wait. Oh, never mind.
All right.
Look at your two.
Look at number 6. Is that one a polynomial?
No.
No, it is not, because you have this radical with x inside it. So this would actually be a radical function, not a polynomial.
Do we need to write that out? Oh yeah.
No.
This 3
All right, but I want to kind of make note of something. Would that be a polynomial?
Yes.
Yes, this would be a polynomial because the square root of 2 is your leading coefficient. It's not, it doesn't have x in it. Does that make sense? So you're really needing to pay attention to where x is when you're trying to decide where, if it's a polynomial
But
or
if
not.
the square root is over an x, it's not.
Right, so if the square root did that, y'all need to stop or I'm going to separate you. Yes, if the square root was over everything, then it would not be a
What if it was only
polynomial.
over one of the x's? And the,
Still not a polynomial. So if it was like
if there's
this,
any x's under the square root, it's not a polynomial.
right.
Tight.
Okay. Kind of like what you said, if it's looking confusing, it's probably not a polynomial. All right, the next thing we're going to do is end behavior. Now, we've talked about end behavior before. The poster is still up there, but now we are going to write it with limit notation. All right, and so when you're doing your test and you're doing your homework quiz and you're doing your homework, if you don't write limit notation correctly, I am going to count off. All right, so some people are asking, do I have to write the LIM? Yes, you do. Do you have to write the f of x? Yes, you do. Do you have to have your equal sign in the correct spot? Yes, you do. It has to look like that. Otherwise, it's not making mathematical sense. All right. The chart works the same way as it did before. If you have an even degree, your end behavior is going to go in the same direction. It'll either both go up or both go down. If your leading coefficient is positive, it will go up. So if it is even degree, positive leading coefficient, you're going up and up. If you have an even degree and a negative leading coefficient, you're going down and down. If it's odd, they're going to go in different directions. So an odd degree means your end behavior is going to go in different directions. Either it will go the right side will go up or the right side will go down. And the other one will go the other way. So odd degree, positive leading coefficient, the right side is going to go up, the left side is going to go down. Odd degree and negative leading coefficient, the right side is going to go down, the left side is going to go up. Okay, so let's talk about the notation for a second. Okay, limit notation is just a different way of writing end behavior. It's just trying to get you ready for calculus. When you start seeing that limit notation, you already kind of understand the way it's written. All right, but we've already answered the question. All right, the LIM just stands for limit. The x approaches infinity is the same x approaches infinity that we used before. So really what we're doing is we're including the LIM. Now, if you're approaching positive infinity, you're talking about the right side of your graph. If you're approaching negative infinity, you're talking about the left side of your graph. Does that make sense? Okay, so the LIM is the same on both of them. Positive infinity is the right side, negative infinity is the left side. You do need to have f of x after the limit and then your equal sign. So the way you read it is the limit as x approaches infinity of f of x equals, and then that is your answer. And then this one is read, the limit as x approaches negative infinity of f of x equals, and then that would be your answer. Does that make sense? Okay, I do not have the limit notation on a poster over there. You do see sprinklings of, do you have limits somewhere? Right here, you have some limits.
Is it that big thing that says limits?
Yeah, but like the way the notation is written. You can kind of see it on some of these posters over here. But you do need to know the way that you write it. Okay, limit x approaches f of x equals. Got it?
Yes, ma'am.
All right.
Here, can you make a poster like that,
No.
please?
All right. For the following polynomials, we're going to state the degree, the leading coefficient, the turning points, and whether it is even, odd, or neither. And then we're going to sketch the graph. It's going to be a sketch. It's not going to look exactly the same thing. But throughout this unit, we're going to get more and more information about our polynomials so we can get a more and more accurate sketch of my graphs. And at the very, very end of the unit, you can see it in 2 weeks on Thursday. We're going to have just a day where we're going to practice sketching polynomials after we find all the things that we find. All right. So first thing is the degree. What is the degree? 3. And what is the leading coefficient? -1. All right, the degree and the leading coefficient are going to tell you your end behavior. So that is all you need to find the end behavior. Practice writing the limit as x approaches infinity of f of x equals.
Oh, we don't have to write right side.
And then, yeah, you don't have to write right side and left side. The limit as x approaches negative infinity of f of x equals. All right, so when you're doing your homework, practice writing the correct limit notation. So when you do your quiz and your test, you know how to do it. All right, since my degree is odd, are they going to go in the same directions or different directions?
Different ones.
Different. My leading coefficient is negative, so what is the right side going to do?
Negative down.
Down. Yep, so negative infinity, the right side's going to go down. What's the left side going to do? Go up. Because it's odd, they're going to be different. So I don't know what's happening in my graph, but I do know that the right side's going to go down and the left side's going to go up.
Wait, how do we know that?
The end behavior. That's what I just did. Because of the degree and the leading coefficient.
Oh, the degree is positive.
Odd.
Wait, odd?
And the leading coefficient's negative. Mm-hmm. All right. So now I'm going to answer the other things.
Max turning point 2.
So how many turning points could I have?
2.
I could have 2 points. And the even, odd, and neither. All right, so that was also kind of an old thing. So we also have our even, odd poster up there. Even graphs will reflect over the y-axis. Odd graphs are going to rotate about the origin. Now, because we're talking about polynomials, all right, polynomials just have a bunch of exponents. If all of your exponents are even, it's even. If all of your exponents are odd, it's odd. If there's a mixture, it's neither. That's kind of the shortcut for using the even and odd. So if you look at number 12,
Odd?
I've got a 3, and what's the understood exponent right there?
1.
A 1. So are they all even or all odd?
Odd.
Odd. So since they're odd, it's going to be, you could rotate it about the origin. So make sure when you draw your 2 turning points, it does, that kind of look bad. you make it where it's kind of like symmetrical.
That's what mine looks like.
Yeah.
That's kind of.
Today.
Why does it look like that?
No.
That's kind of confusing. So it's like a lightning bolt?
Mm-hmm. All right, let's go to 13. Let's try another one. All right, first, what is my degree?
4.
4. What's my leading coefficient?
1.
1. So from that, we can figure out my end behavior. So the limit as x approaches infinity of f of x. What's the right side going to do?
Positive.
Positive, because it's even and positive. The right side will go up. What's the left side going to do?
Positive. Also go up.
Also go up, because even is going to go in the same direction. So the limit as x approaches negative infinity of f of x is also going to go up. So I know the left side and the right side, they're both going to go up. How many turning points can I have? 3. All right, I can have 3. We don't know if I have 3, but that's the max number. And for my exponents, I have a 4, a 2. What is the understood exponent if there's no x?
0.
0. And 0 counts as an even number when you're doing even, odd, neither.
It's a wild card.
So 4, 2, and 0, are those all even or all odd, or is there a mixture?
Even.
All even. So we have to draw it so it looks like it can fold across the y-axis, which normally will just naturally happen. So turning 1, 2, 3. So just make sure your turning points are kind of symmetrical as best you can. Otherwise, it wouldn't matter.
So it's a W.
So it looks like a W. A symmetrical W.
And that's because it's even. So when it's odd, it's a lightning bolt. When it's even, it's a W.
Not always. All right, so let's do this next one. All right, so the degree is going to be
5.
5. The leading coefficient is
2. Oh, I was
2.
thinking 15. It was right under it.
You're right. All right, the limit as x approaches infinity. So the right side of my graph, it's going to be infinity because my leading coefficient is positive. The right side's going to go up. All right, now the left side, negative infinity, because my degree is odd, they should be going different directions. So that one's going to go down. Okay, turning points. How many could I have?
4.
4. And is it even, odd, or neither?
Oh, because 0 counts as even.
Yeah. So I've got 5, I've got 3, but because of this x0 here, 0 counts as an even number, so it would be neither. So you do not have to worry about your symmetry at all. So it doesn't matter how high or how low your turning points go. We're just going to turn 4 times. So we're going to go 1, 2, 3,
Wait, so
4.
0
0
is even?
is even.
1, 2, 3. I'm counting 3
What?
on your.
I'm not getting how you're getting these shapes at all.
So you got to turn 1,
It's how many
2,
humps
3,
there are.
4.
1, 2, 3, 4.
So hump 1, hump 2, hump 3, hump 4.
They don't have to look the same, right?
It was a small hump on the first one, yeah.
Oh, I was very.
Do they have to look the same? Or
No, this one, because there's no symmetry, doesn't have to be
So
the
it
same.
doesn't matter how we draw our humps.
Nope.
So I could draw it like the opposite, like the first one up and whatever.
Yeah.
Demonstrate.
So like if I wanted to, I could flip that squiggly line upside down, and it would still be the same thing.
I think so.
Yes. I've just been drawing it.
So you're saying go 1, 2, 3, 4, like that?
Yeah.
Yeah.
Okay.
And then 1, 2, 3, 4. You just have 4 turning points. So on this one, the symmetry doesn't matter, so it doesn't matter how you draw your humps. If there is symmetry, you just have to make sure you draw everything symmetrical. All right, on a 15. What is the degree on 15? 2. What's my leading coefficient?
-1.
negative 1. All right, so now we're going to do end behavior. So the limit as x approaches infinity of f of x is going to be negative infinity. Because the leading coefficient is negative, I know that that right side is going to go down. Okay, now the limit as x approaches negative infinity of f of x is going to be negative infinity. Why are they both going to be the same?
Because it's the last example.
No.
Oh, even.
Because it's even. Because the degree is even.
Yeah.
All right. How many possible turning points can I have? One. And is it even, odd, or neither?
Neither.
It's neither.
Here's the 0. I'll say
So that's a 2. What's the exponent with the x?
0.
1. And then this one is 0. So if the x isn't there at all, it's 0. But if there is an x there, the understood exponent is a 1. So 2 is even, 1 is odd, 0 is even. So you can draw, yeah, however you hump, wherever it goes, doesn't matter. It doesn't have to be. Oh. Okay, that's fine. Doesn't matter. Doesn't have to be symmetrical at all because it's neither.
So you can help however way you want.
You only can do it one time though, so it's got to go that way. You can't do this. That would be wrong.
But that's one hump.
No, it's not. It's 3. 1, 2, 3.
Oh.
So you only can go whoop, just like that because it's a quadratic.
Mm.
So it only can have one mountain. All right. So let's talk about your homework now. It should go by pretty quickly. I think most everybody in second period said they finished their homework in class. On 1 and 2, you're just telling me the degree, the leading coefficient, and if it's a polynomial or not. If it's not a polynomial, you do not have to answer the questions. And then 3 through 8 are matching with the functions down below. And then on the back, kind of like what we did on the notes, make sure you're practicing the end behavior with your limit notation. And like I said, I don't have you sketching graphs now, but as we get more into this unit, we are going to be sketching polynomial functions. So just kind of keep all of those things in mind and how they relate to a graph. What's up?
On 11, since it's just 4, would the degree just be 1 and then go like this?
So the degree, because technically this exponent is a 0, so the degree would be 0.
And then
Leading coefficient would be 4.
My notes.
You wouldn't have any turning points.
When you want them, you want my notes?
Would it be even, odd, or neither?
Why?
Even. And then for the end behavior, I think it helps if you look at the graph. So what does a function y equals 4 look like?
I know you remember.
it's just straight line.
Yes. So as you're approaching infinity, what's your graph doing? Is it going up or down?
No,
What's it staying at?
4.
4. So you would say the limit as x approaches infinity of f of x equals 4. H of x. And then similar for the negative infinity.